Assalamualaikum warahmatullahi wabarakatuh. Introduce, my name is Ika Yulandira, ID 190384204117. Facultas of Teacher Training and Education Chemistry major. This video was made to fulfill my colleagues' achievement courses Bahasa Inggris untuk Kimia. In this video, I will discuss a journal entitled A Regional Perspective on Urbanization and Climate-Related Disaster in the Northern Coastal Region of Central Java, Indonesia. Okay, Indonesia as an archipelago national has about 115 million people, 16% living in coastal area. Such communities are increasingly vulnerable to the effect of change in the form of sea level rise and strong, more intense storm. Population growth in coastal area will also increase the disaster risk, mainly because of climate change related effects as flooding, droughts, and tidal flood. This study examines the dynamic change of urban population and urban village in the geological period. The analysis was conducted in the northern coastal area of Central Java province using village potential data, which are routinely collected by the government. Research show that about 41% of people in Central Java province and live in the northern coastal region, and 15% live in urban areas. Activity and Sociality, a growing body of research, also show that climate change constitutes a serious threat to the sustainability of urban development in many countries, especially with a large number. Natural disasters include biological, meteorological, geophysical, hydrological, and climatological phenomena. Most climate-related disasters, such as flood, tidal flooding, and windstorm, affect coastal area. The coastal area is a dynamic area where there is interaction between land, water, and atmosphere, with human activity also playing. Areas are also considered preferable to inland areas in the terms of settlement, high population density, infrastructure development, and other sporting facilities have made to the coastal urban areas. Migration patterns from rural to urban areas due to disaster risks were found in the developing countries that were characterized by low-income urban settlement, with about 13 million of the poorest people moving from rural to urban areas per year. This phenomenon is also found in most Indonesian cities located in the coastal areas, particularly on the island of Java, where about 16% of Indonesia's total population live. From a total of 118 districts and or cities on Java Island, more than half are located in the northern coastal areas. Different activities in this region have evolved from basic coastal activities, using rainwater research from surrounding. The scope of the paper it shows different types of climate-related disasters occur in the northern coastal region of Central Java in the forms of population growth rate, density rate, and distance from the coastline to highlight development status. We also provide context for the urban and rural conditions from different periods to figure out change in specific region in the northern coastal area of Central Java. Okay, next, material and method. First, to the area. The northern coastal area of Central Java was selected as to the study area. Coastal area boundaries and the research are defined as the district administration boundaries. All districts located along the northern coastal area of Central Java are regarded as the research area. Administration. There are 14 cities or regions in the northern coastal regions, of which 4 are Tegal, Pekalongan, Semarang, and Kudus. And 10 other are regions, Brebes, Tegal, Pemalang, Pekalongan, Batang, Kendal, Demak, Jepara, Pati, dan Rembang. In the term of development, northern coastal area were considered the most developed region in Central Java. Here's map of the area taken in this mode. 2. Next is data collection. Village potential data collected by the Central Bureau of Statistics or BPS. Data were classified into the major areas, urbanization and climate-related data. Data on urbanization are related to population density and urban-rural status, while data on climate-related data are responded by the number of flood, tidal flood, and drought event in 2010. Third, to those grade of this data that were identification from 3151 village or urban village exposed to this data in study. The next three methods. Data were transformed into spatially explicit data with graphical information system, or GIS, based software to show data available in each village or urban village. The spatially explicit data were then classification following the map classification. All spatial explicit data in this study are managed and organized under GIS as it has better database management capability than other information systems. Next, 4. Map classification. Map classification was applied for density, urban-rural status, population growth, and distance from coastline. Data from village or urban village were identification and classification to identify built up area, population, and density for the respective year. Population density was classification into 5 classes and urban-rural status into 4 classes in the fight from the built up area data in 2010. This is 5. Population growth and density. Population growth in the number that show the population change within a specific period and is respond as percent of the initial population to identification growth rate. This study used a geometric method in calculating in the population growth as applied by BPS geometry. Growth refers to situation where success changes in population differ by constant ratio. The geometry population growth R is calculation as follows. And the intent of the density calculation is to measure the number of people living in area and distinct which location are denser compared to other. The population density D is determined is full status. The following is table of variable and criteria for rural-urban classification. Rural-urban status in this study was different from variable and criteria that have been applied by BPS in determining rural-urban status. In test variable are population density, percent of farming household, percent of salt shed by electric, percent of household served by telephone network, access to main urban facility, and access to sporting facility. Variable and criteria in classing rural-urban status. And the next, map overlay. And the finally analysis step that on population growth rate, distance to coastline, and type of this data were combined by employing the overlay analysis in GIS from the overlay analysis. The hazard event can be identification by looking at data cross tabulation that result from the overlay analysis. The relationship by one class relate disaster and urbanization future represented by population growth at wash well distant from coastline. Can the broad show the typology of math overlay and cross-tabulation analysis in this.